Welcome. I'm glad to see you studying hard for your exam. In this video, we have a question about impulse. The concept of impulse can be hard to remember. I have a very smart student who once tripped on impulse questions 3 times during exams. But don't worry, I have found a good analogy that will help you understand it clearly. And this is a friendly question, so you're not going to feel too burdened. You may pause the video and read the questions. When you're ready, hit play. Let's identify the key features of this problem. Look at the axis. It's a force versus time graph. Whenever you see this kind of graph, it's testing impulse without fail. Notice how the graph makes an area with the horizontal axis. That area equals to the impulse, which also equals to the change in momentum of the object. Let's pause and think. If impulse and changing momentum are equal, why do we have 2 names? I would put it this way. Impulse and changing momentum have a cause and effect relationship. Here's an analogy. Think of kicking a football. The impulse is a push your foot gives during the short contact. That's the cause. The changing momentum is how the ball flies off faster in a new direction. That's the effect. So they are equal in size, but not in meaning. If this part feels tricky, it's totally normal. Pause and replay as needed. Now let's move on to the equations. Your formula sheet may say that impulse is force times time, the duration of contact, and the changing momentum is delta mv. Is it correct to plug 100 Newton into F? No, that equation applies only if the force is constant. Here, the force changes with time, and 100 is just the peak value. Let's move on to the logic chain and build the reasoning steps. First, the area under the graph equals to the change in momentum of the object, delta mv. The area on the graph has a shape of a triangle, so the area is half times the base, delta t, times the height, the peak value of f, and this equals to the change in momentum of the object. From the question, the mass is a constant, and its velocity changes. Now to the working. Start with the equation from the logic chain. Plug in the numbers. Work out delta t, which equals to 0.3 seconds. So the answer is B. Quick recap. In this video, we learned the concept of impulse and change in momentum. Impulse is the cause. It is the total push a force delivers over a period of time. Changing momentum is the effect. It describes how the object's motion changes as a result. We also talked about the restriction of the impulse equation. This equation applies only if force is constant. But if you're in a more advanced curriculum, you may know that if force varies with time, you can calculate the area using integration. If my structured problem-solving videos have made your study easier, please let me know in the comments. Your feedback really motivates me to make more.